Hello guys, welcome to my channel Java Junction. Today we'll write a program that will solve three problems related to number and digit. The first one is find the sum of all the digits in a number. Second one is to find the reverse of a given number. And third one is to check whether the given number is palindrome or not. Without any delay, let's move to our Eclipse IDE directly. Here we have our boilerplate code ready in Eclipse IDE. We have a class with class named digit number, inside which there is a main method. Inside the main method, let's create an integer type variable n and assign its value to, let's say, 5432. We are going to find the sum of all digits in number n, find the reverse of n, and check whether n is palindrome or not. Now let's create a loop. While n not equals to 0, yes, our loop is created. Let's run the program. I press F11 to run the program. While running the program, we see that the red rectangle at the console, which means our program is not terminated. It's because here n equals 5432, which is never equal to 0, and when n is not equal to 0, this while loop is running. And the program never gets out of this while loop. So let's say the statement n equals n by 10. With this statement, n is revised in each step, being divided by 10 from the previous n value. Let's again rerun the program. We see that our program is terminated as there is no red rectangle, and here we see terminated written in the console. To see how n is decaying to 0, let's print n inside the loop. System.out.println n. Here, at first 5432 divides by 10 give 543.2. Since we are assigning n by 10 to n itself, which is an integer type data, n will take 543, omitting everything after the decimal place. Also, in the next step, 543 divided by 10 is 54. Next, 54 divided by 10 is 5, and eventually n becomes 0. Now let's create another variable, int rem. Rem will take remainder when n is divided by 10 at each iteration. So inside the loop we write rem equals n modulus 10. Here the modulus sign means n is divided by 10 and the remainder value is stored to rem. Now let's see the value of rem at each iteration. We see that rem value is 2, 3, 4, 5 at first, second, third and fourth iteration. That is, we are getting all the digits of number one by one from the right side at each iteration. So if we add rem at each step, we will get sum of digits in a number. So let's define int sum and initialize to 0. And inside the loop, let's add rem to the sum. That is, sum equals sum plus rem. Now let's print the sum and run the program. We see that initially sum is 0, adding 2 it's 2, adding 3 it's 5, adding 4 it's 9, and again adding 5 it's 14. So at the end of loop, we get the sum of all digits of the number. To find the reverse, let's create a new variable rev and initialize it to 0. Inside the loop, rev is updated at each iteration as rev equals rev into 10 plus rem. Again, let's print the value of rev at each step. Initially 0 multiplied by 10 plus 2 gives 2. Next iteration 2 multiplied by 10 plus 3 gives 23. And the next iteration 23 multiplied by 10 plus 4 gives 234. And eventually at the end 2300 45, which is exact opposite of 5432. So in this way, we can get both the sum and reverse of the number at the end of the loop. Outside the loop, let's print both sum and reverse. Let's write system.out.println. The sum is sum and system.out.println. The reverse is rev. To check whether a number is palindrome or not, we need to check this rev with the original number. Our original number is n, but during the looping operation, the value of n became 0. So, to save the original number, we need to store the value of n to another variable, let's say for now temp, and so that we can make comparison of temp with the rev. So we'll write int temp equals n, so that we can assign the value of n to temp before the loop, and after the loop we'll write if rev equals temp system.out.println palindrome, else system.out.println not palindrome. Now let's check the result for few more number. For n equals 1567, not palindrome. N equals 121, palindrome. 1221, palindrome. Let's understand how the compiler works on the code. Let's take a particular test case with n equals 1234. For the first iteration, rev equals n modulus 10. That is 1234 modulus 10 is when you divide 1234 by 10, we get 4 as remainder. So rev equals to 4 for the first iteration. Also, n by 10 is 1234 by 10, which is 123.4. So if we assign 123.4 to n itself, which is a integer type variable, n will takes only 123 and omits everything after the decimal. So new value of n is 123. Sum, which was initially 0 outside the loop, is now updated as sum plus rem, that is 0 plus 4, which is equals to 4. Rev, which was initially 0 outside the loop, is now updated as rev multiplied by 10 plus rem, that is 0 multiplied by 10 plus 4, which is equals to 4. In the next iteration, the new value of n will be 123. N modulus 10 is 123 divided by 10 and remainder is 3. N divided by 10 is 123 divided by 10, which is 12. Sum, which was initially 4, is now revised to sum plus rem, that is 4 plus 3 equals 7, and rev, which was initially 4, is revised to rev into 10 plus rem, that is 4 into 10 plus 3, which is equals to 43. In the next iteration, n is revised to 12 and the looping will continue until n reaches 0. At the end of the loop, we get sum is equal to 10, which is sum of all the digit of the number, and rev equal to 4321, which is exactly opposite of the initial original number 1234. Thank you for watching my video. I hope you liked it. I would like to make a humble request to everyone to like, comment and subscribe to my channel, which is the only source of motivation for me. In the next video, we'll talk about Armstrong and perfect number. Till then, stay tuned. Have a nice day. Bye-bye.